Hello everyone, today let's solve the problem Little Girl and the Game. So this was asked in the Codeforces round 169 division 2, right? So let's see what the question states. You can just go through the question. It's very easy to understand. This is basically rated 1300. This is easy question, to be frank, right? So you can just go through the question. It's easier to solve. Basically it's easier to understand. So I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states here. Just give me a second, 1 second here. Let me change the color, man. 1 second. Yeah, so now, so what the question states here, we are given a lower case string s. See here, we are given a lower case string s. For example, so within the strings we can have anything, a, c, z, x, y, anything, right? So we are given a lower string s. Players alternate removing any single letter, right? Players, what do? They alternate remove any single letter. Before each player's turn, if the letter of S can be permuted into a palindrome, that player immediately wins. So see here, what's the condition here? Before each player's turn, if the player of S can be permuted into, if this can be permuted into palindrome by a player, any player, right? So by player, then that player immediately wins, right? So there are only first and second. Let's assume this one. Only first and second player is playing this game, right? So we have to determine who wins, basically, first or the second, assuming both play optimally, right? For this particular question, let's assume there are two players, first and second. So we have to determine who wins, first player wins or the second player wins. If the first player wins, we have to return the output in the string naming first, basically, right? Else we have to return second. Right? So this is the question, basically. Like, again, I'll just read out the question loud. Just listen to this carefully. So this is one of the easiest question to solve. See here, we are given lowercase string s, right? So players alternate removing any single letter, right? So before each player's turn, if the letter of s can be permuted into the palindrome, that player immediately wins, basically, right? So we have to determine who wins, first or the second, right? So assuming both play optimally. So this is the question, right? So here, see, let's come to the input output part. We have a string ABA, and here in this case the first one wins, right? So same goes with the second one, second input as well. Here in this case the second player wins, right? So this is about the question in the input output part. So this is easy, basically, right? So let's do one thing. As we are familiar with the question now we have the understanding of the question, right? Let's do one thing. Let's quickly discuss the complex this one approach, followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So I have considered the same first example that they have given in the question, or the first input they have given in the question, AB, right? So the output that we need to get here is first. Basically, first player has to win here in this case, right? So one thing before moving on with the further things, so I just want to tell you that we'll be making use of the dynamic programming to solve this particular problem, right? So let's move on with a step-by-step explanation, right? So this one. So what we'll be doing here, we will be computing the frequency of each letter and count how many letters have odd frequency count, right? Suppose A, B, A, here we are going with the frequency of each letter. See, A is having the even frequency 2 and B is having the odd frequency 1, accordingly with the question, right? Next, what we will do, we will define dp of k. What's dp of k here? So dp of k is equivalent to, can the player about to move when they are k odd frequency letters. So this is nothing but dp of k. Just try to remember this. Can the player about to move when they are k odd frequency letters? Let's move on with the next question. So let's go with the base case. So dp of 0 is true. dp of 0 equals true and dp of 1 equals true, right? So this one will set dp of 0 equals to 2 and dp of 1 equals to 2, true, basically. For k greater than or equal to 2, so for k greater than or equal to 2, so here this one, when k greater than or equal to 2, the current player can remove a character from an odd count. Current player can remove a character from the odd count letter, right? Just try to remember this. This is very important point, right? So for k greater than, in this case we have this one, 0 and 1, right? So for k greater than or equal to 2, the current player can remove a character from the odd count letter to turn one odd into the even, right? So this is fine, I believe, right? So we have to move to state k minus 1. So dp of k should not be equivalent to the dp of k minus 1, right? So this is fine. This you will get to know when we write the code. So this alternation gives dp of k equals true for the k equivalent to 0 or odd k, right? So let's try to implement the same thing in the form of this one in the example. Basically for the example 1 you'll get to know, right? So s we have aba, so the example same thing, right? Count, so this one first, as we said, we'll be going with the count a. Frequency of a is 2 and frequency of b is 1 here, right? So we have odd 1, right? So we have odd 1, meaning b we have 1, right? So dp of 1 is true basically here. dp of 1 is true. So basically what happens, dp of 1 is true, so first one wins here in this case, accordingly with the approach that we discussed, right? So odd equals 1, 1 odd we have, that is b equals 1, a is even, right? So we have a equals to 2, 1 odd we have, odd equals 1. So dp of, we can just directly go with dp of 1, nothing but initially dp of 0 and dp of 1 we have given true, odd 1 we have, dp of 1 is true. Here first one directly wins basically, right? So the output that we have to return here is first basically in this case, right? So the output that we got here is first, which is equivalent to the output that they have mentioned for the example 1 within the question, example 1 within the question, right? So our approach works absolutely correct in this case, as we are completely familiar with the approach. So this is basically the DP idea and how we implement that one for the example. That one also I have shown basically, right? So now let's move on with the complexities part. So what would be the time complexity here? The time complexity would be big of n, right? Where n is nothing but equivalent to the string s that they have given. So building frequency takes this one, what big of n, and counting the odd ones also, it is big of 26 because we have 26 letters, right? So basically we are going with the lowercase letters for this one. This problem they are strictly mentioned in the question itself, lowercase letters, right? Building frequency takes big of n, counting odds we have to go with the big of 26, and filling the DP would take big of n. Overall linear, right? So overall time complexity would lead to big of n. So what would be the space complexity here? The space complexity would be big of n due to the DP array of size n plus 1. The space complexity would lead to big of n due to DP array of size n plus 1, right? So we have big of 1 for the frequency array of size 26 as well, but overall it would lead to big of n, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So now as we are completely familiar with the approach and the complexities, we're good to write the code. Let's start writing the let's start writing code. First we'll be making use of the fast input and the output. So let me import input output package, right? So this is fine. Let's go with a class. Just go with a class named main as usual. So I can just give any class name that's relevant to the question. So I'll just go with the main method here. So this one, let me include throws exception as well, or else we'll be getting the error basically, right? So within the main method, the first thing here would be, let's go with the input output part. So let me go with buffered reader, right? So this one will be new buffered reader, new input stream reader of system.in. So this is fine. The next thing would be we have to read the input string s that they have given. In our case, for the first example it was ABA, right? So we have to read all the input strings. So I'll just go with the string s equals, so buffered reader dot read line. So this is fine, man. Next step is let's go with the frequency array for 26 lowercase letters. They have strictly mentioned lowercase letters, right? So let's go with the frequency here. We have to consider array itself, right? So this one new int 26 letters, right? So I'll just give you size 26. This is fine. Now we have to count each letter's occurrences, nothing but the frequency. So this one will be char c of this one s. Let's make use of the 2 char array here. 2 char array. This is fine. So this is Java. Let me give the parenthesis here. So this one will be f of c hyphen a. So let me increment this one. this is fine. Next, let's do one thing. Let's go with a number of letters with a odd frequency. Initially, let me initialize odd to 0, right? So also, if the frequency is odd, then we have to increment the odd count, right? So for that, let's go with the iteration part here, and x of f. Now, if this one, if the frequency is odd, right? So let me go with x bitwise and 1 equals 1. If the frequency is odd, then we have to increment the odd count. So let me increment odd. This is fine, man. This is easy. Now, as I've said, we'll be going with a DPR, right? So dp of k here, it is nothing but whether the player whether player about to move wins with a k odd counts or not. That's what dp of k is, right? So initially, let's consider the dpr first, which is of the type boolean. We are going with the true or false, right? So dp equals new boolean of this one. I'll just go with the length of the string s plus 1 size, basically, right? So this is fine for the safer side. Now if the zero count, if we have 0 odd counts, then it can be permuted to the palindrome now, right? So this is nothing but current player wins here. So if the dp of 1 is true, if we have 1 odd count, in our case we had 1 odd count, so this one player first, this one first player directly won, right? So that was the condition we discussed in the this one approach, right? If 0 odd counts, then current player wins. If 1 odd count, then also current player wins. dp of 0 is true and dp of 1 is also true. So this one we had discussed in the approach, basically. So I'll set this one dp of 0 equals true. So next, dp of 1 equals true. This is fine. So next what we will do, let's move on with the iteration part. So this one for int, so we have to calculate k greater than or equal to 2. That one we discussed, right? So for we have to iterate from the value 2. So I less than or equal to s dot length. So this is fine. Let me go with I plus plus. So within the for loop, so this one will be dp of I equals not of dp of I minus 1. So this is fine. So we are going with the recurrence in the sense, from I odd counts the player can move to I minus 1. So dp of I equals not of dp of I minus 1. So this is what we discussed in the approach, right? So finally we have to output the winner based on the dp of odd, right? So I'll just go with the this one. Let me come out of this one entirely. Let me go with system out println, basically, right? So this one would be if dp of odd, then first one wins, basically, else the second one wins, basically, right? So this one I'll just go with second, right? So this is fine, man. Yep. This is it for the problem, basically, simple one, right? So basically easy one. So now before checking the code with the different inputs or the examples, let's do one thing. Let me quickly this one copy paste the signature starter template. So I'll just come here. Yep. Let me come here. For this one, the output that we need to get here is first, right? So let's check. Method to carrier. Cannot find the symbol. Oh, this C carrier. This C has to be capital, man. Line number 27. Yep. We run this one again. Yeah, we are getting the correct output first, basically, right? So next, let me copy this one. We have to get the output second, right, for this particular input ABCA. So we are getting the second. So our code works absolutely correct. So let me copy this one entirely. Let me hit the submit button. Yep, in the submission part, so let me consider B, little girl and the game, right? So let me paste this one. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. I hope this works. Let's see. Let's wait for some time. So this one is stuck for the long time basically. Whatever the code that I submitted is showing in queue itself, right? So now this is not getting this one basically getting judged. I don't know why. So here is one thing. So I have checked this one. This one works absolutely correct, right? So I have this one. I had practiced this question earlier as well. So I had submitted this one, the same code basically, right? So here you can just try this one if you're following along with the code basically. You can just try this one. So this works absolutely correct. You can just try this one without any hesitation. So this works absolutely correct, right? So this is fine, man. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.